Hello everyone, this is Professor DePaulo. Welcome you to this problem set involving z-scores. So I'm going to take a look at what z-scores are, how to use them for comparison's sake, and then finding areas under the curve or probabilities within the normal distribution. So let's start with an example here. John scores 75 on his biology test and 70 on his psychology test. The class mean for the biology test was 70 with a standard deviation of 7. The class mean for the psychology test was 65 with a standard deviation of 5. On which test did John perform better? Please show your work justifying the answer. Okay. So first we're going to start by converting to z-scores because we're comparing we're comparing two different metrics. A biology test is a different metric than a psychology test. They're different measures. So in order to compare two different measures, we must first convert to the common z-score, the standardized score, and then we can compare z-scores. So let's start with the first one. So we know that the John score 75. Let's call it x1. And we know that the mean was 70. And we know that the standard deviation was 7. So to find the z-score, it's the raw score minus the mean over the standard deviation. This gives me 5 over 7. And this is 5 over 7. So it's going to be about 1428. It's going to be about 0.70, but I'm going to do the exact calculation here. 5 divided by 7, 0.714. So rounded to 0.71. So that's my first z-score. And then for my second one that I'm comparing, we see that John scores 70 on the psychology test, and the mean of the psychology test was 65, and the standard deviation was 5. So that becomes z of 2, second z-score, 70 minus 65 over 5, which is 5 over 5, which is 1. So now we have to compare a z-score of positive 0.71 and a z-score of positive 1. Obviously, the z-score of positive 1 is greater, so it's the second test. So John did better on the psychology test than he did on the biology test, so psychology is better. So the raw score would indicate that the biology test was higher, 75 to 70, but the z-score indicates that the psychology test was better because he did better relative to the rest of the class. So psychology test better, for lack of more creative conclusion. So that's like the first type of problem where you're going to compare z-scores. You're converting to a common metric, which is the z-score, and then you're comparing two z-scores. You can easily compare them to each other. You can't compare the raw scores because they're on different measures. They're different scales. But the z-scores we can directly compare, and we know that the psychology test was better. Let me put a was in here so I can. It sounds somewhat like English. Psychology test better. No, it's like sort of a caveman speak. Psychology test was better than the biology test. Right. Just getting lazy here. Psychology test was better. So let's look at the second problem. Stats exam has a mean of 70 and a standard deviation of 10. Jim scored an 85 while Mary scored a 75 on the exam. What percentage of all students scored between these two scores on the stats exams? Assume the scores are normally distributed. So when I say assume the scores are normally distributed, that means z-scores. Because that's what we're using with a z-score. We're using normal distribution, what's technically called the standard normal distribution, with a mean of 0 and a standard deviation of 1. So let's now compare these two or find the area between. We We need to convert to two z-scores if we're going to find the area between. So we know that Jim scored 85, Mary scored 75. That's going to give us the two z-scores. So let's do mean 70, standard deviation is 10. And Jim scores 85, and Mary scores 75. So we're going to create two z-scores. So first for 85. So that's the first z-score, z1. 85 minus 70 over 10. It gives us 15 over 10, which gives us 1.5. So that's Jim. So Jim scored, had a z-score of 1.5. Now let's look at Mary. Mary got 75. So we're using the same formula, z equals x minus m over s, or z is x minus mu over sigma, depending on, this is if we have a sample, this is a population, but they're exactly the same, so it doesn't matter which one you use. It doesn't matter. They're exactly the same, giving you the same answer. But those are the z-score formula. So z2 is 75 minus 70, once again over 10. So this is 5 over 10. So this is 0.5, and that's Mary. What's important here is we draw the curve. So this is going to be an ugly looking curve on the tablet. The tablet is a little bit annoying to draw curves with. Here's 0. And we got 0.5 here. That's z of 0.5, that's Mary. And then Jim is out here, approximately 1.5. And we want this piece, the shaded piece. We're looking for the percentage of scores in this shaded area. Well, according to the table, the normal distribution table, which I'm going to show you now. So we have a couple of different scenarios here. We're going to use, since we want to find the area between those two scores, we're going to use column D here, which is mean to z. So since the two z-scores are on the same side, so they're both positive, we're going to take the bigger D area and subtract the smaller D area. So what does that look like? Let's go back to the whiteboard. So we have a D area here. So mean to z is this. That's D. That's D for 1.5, right? That distance here. This is D for 1.5. And here, the smaller area from 0 to 0.5, this is D for 0.5. So that small area here from 0 to 0.5, that's D for 0.5. And this bigger piece from 0 to 1.5 is D for 1.5. So we're looking mean to z for 1.5 minus mean to z for 0.5. So let's find the D for 1.5 first from the table. So we scroll down to 1.5. We find D, and it's this value right here, 0.4332. So 0.4332 is the bigger piece. That's the piece here from 0 to 1.5. Now we want the piece from 0 to 0.5, so we got to look up 0.5 in the table and look at column D. So let's look up 0.5 in the table. Look right here, we want column D, it's 0.1915. 0.1915. So we're just going to do this. Bigger piece minus smaller piece. Both of them are D in the table. D column in the table. So this is 7. This becomes 1. 13 becomes 4. This becomes 2. So 2417 is the difference in areas. Okay, so that's the shaded area. We want this as a percentage, though. That's the shaded area here. That's not a great, sorry, that's not a great arrow I drew here. Oops. Now I destroyed the curve. Let me undo that. There we go. That's not what I meant to do. I wanted to erase this little piece in here, but I can't. So we want to convert this to a percentage. So this is a probability or an area, depending on how you're looking at it. To convert to a percentage, multiply by 100. 24.17%. So that area here, shaded, is 24.17%. That is the percentage of scores between Jim and Mary on the exam. 24.17%. So the bigger D piece minus a smaller D piece. Now, if they're on opposite sides, if you have a positive z-score and a negative z-score, then you just add both pieces. You would add the piece on the positive side for D and the piece on the negative side for D. But since they're both on the same side, we have to use the bigger D piece minus the smaller D piece. Remember that you can only get positive numbers here, or 0. Right? You cannot get negative areas. You can't get negative percentages. So if you're getting a negative value, you're doing it wrong. Do the bigger piece minus the smaller piece. So that was that problem. Let's look at the next one. So this is IQ, not Q. Sorry, that just got cut off. IQ is normally distributed with a mean of 100 and a standard deviation of 15. The minimum IQ score to get into Mensa is 135. So this is another Mensa question that I came up with. I actually have to look up the exact Mensa value. It doesn't matter for this problem, but it's pretty high in the IQ range to be in Mensa. What that means, I don't really know, because as we talked about before, IQ is not really a valid measure. Like an IQ test is not really a valid measure for intelligence per se. It's just one of many things. I mean, be able to rotate things in your head and, you know, do these things quickly, what does that really translate to? Pretty much not much. So IQ is kind of an overrated measure of pretty much anything. But in case of Mensa, you can join Mensa, you can have parties with them and whatever they do. I don't know what they do. They do stuff. So let's find what percentage of the population is eligible for Mensa. So that's what we want. What we're really asking here is we want all values of X greater than or equal to 135. Right? That's what we're looking for. Because we want people with 135 or higher. So with IQ, we have a mean of 100. So that's my mean. Standard deviation is 15. And we want everything greater than 135. So let's make it a z-score. Because in order to use the normal distribution table, we need to have a z-score. We also have to assume that that IQ is normally distributed, which we're saying it is. And it generally, in the real world, it is. So we want 135 minus 100 over 15. That gives us 35 over 15. That gives us 2 and 5/15, 1/3. Rounded 2.33. Right? So we got to find that value in the table now. 2.33. So let me get the table out. Where's the table? We want to find 2.33. Now, let's draw the picture first. Let's not forget about the diagram. That helps us see it better. Here is 0. Way out here is 2.33. We want greater, right? Because we want greater or equal to 135. So we want this tail here. This is C in the table. For 2.33, we want the tail. So let's look for that. Let's scroll all the way down to 2.33. We want the tail, which is column C. So that's the second column. It's 0.0099. 0.0099 in the tail. That's an area or a probability. We want to multiply that by 100 to convert it to a percentage. And that becomes 0.99%. So a little bit less than 1% of the population is eligible for Mensa based on these criteria. That's not a lot. Less than 1% of the population. And that's pretty much it for Z-score problems. So hopefully that was straightforward. If you have any questions, let me know. And I'll see you next time for the next type of problem that we're running, which will probably be one sample Z. All right, bye for now.